Welcome everybody to our 44th installment of the OWASP Meetup. I see we are growing and growing, so we will talk a little bit later. We are having some plans how we can evolve this meetup a little bit. But for now, thanks for coming. Thanks for registering on Meetup more or less, so we can see how many people are coming and try to plan accordingly. We are usually having an introduction round, but I'm afraid we are a little bit too many people. So first of all, who doesn't speak German? Okay, cool, then we'll stick with English, no problem. Who's the first time here? So, okay, that's good enough reason to explain. So one of the reasons for our meetup here is that we not just want to talk about the Open Web Application Security Project, but one of the main reasons is to network, to get to know people that share the same interests, that you can reach out to, that you can collaborate with. And therefore we usually have an introduction round like, hey, my name is, I'm working as, I'm here because. Again, if we start this, we're probably sitting here tomorrow. So let's do a little bit different. Who is here today and is writing code as his main job? And that's cool. So maybe just keep looking around so you see some faces that could be like-minded people. Who's working in blue teaming, like SOC analysts, forensics? Yeah, not bad. Who's working in the new hype red teaming, like pen testers and the like? No? You? Yeah, who has nothing to do with IT at all? And just has been bribed to come here. Who's here mainly because of the talks that we have? That will be interesting. Yeah, that's good to know. Who would come even if there's no talk? Okay. I'm just trying to figure out how we can move on with the meetups in the future. Yeah, so I hope you saw a few interesting hands coming up. We will conclude later at the bar, so I hope some of you will stick around so we can talk a little bit. And yeah, otherwise let's proceed. Toilets are just down the hallway on the left behind the reception. I still have no clue where's the fire extinguisher. Oh yeah, one new thing today. We are running a kind of POC. We are recording the session because we were asked a lot of times already, like, hey, what Kevin is talking about was cool. Why can we not record it and see it online? So these are our first little baby steps to see if that makes sense. So in case you're running around naked in the front here, you will be on YouTube later, just so you know. So again, info round. Yeah, so maybe at least, yeah, probably a good idea that I at least say. My name is Johannes Schönborn. I am with OWASP since around 2009, I think. I am helping running the local meetup here since 2014 and running it since 2015, I think. And again, I'm here because I think it's a very good place to exchange ideas, to get feedback without having to put your business card out first and say, hey, we can talk about it if you hire me. So you can skip that stuff. As we have more new people than I anticipated, I will talk a little bit about what is OWASP. Who has no idea what is OWASP at all? Never heard it. Okay, who is using OWASP resources on a daily basis? Once per month? Who has used it at least once, like OWASP Top 10 or something? Okay. Who knows what's OWASP but hasn't done anything with the guidelines, with the materials that are, it's okay. So then I don't need to explain too much about OWASP. Then, well, our main attraction today, we talk with Kevin, and in the end we will conclude in the bar. So the Open Web Application Security Project is also constantly evolving. If you look at the website and you search for stuff like cyber, for example, you will see that OWASP is moving a little bit out of the corner of just doing web application security stuff. But they're also doing a lot of other things. Probably this year we will try to get every meeting or every second meeting one of the main contributors of one of the flagship projects here, like Use Shop or Zap or something else. So that's something where we want to work on to get a little bit more closer to OWASP and to introduce stuff. Who was here last time when Jim Monaco was here? Ah, that's cool. So last time we had one of the, I think, founders or one of the flagship members of OWASP to explain a little bit. So every time we are talking a little bit, I'm giving a little bit heads up of what's happening in OWASP, and one of the main things that is happening around now is that AppSec Tel Aviv was announced for May. So that's a conference there. The interesting part is that last year they also announced this conference and then it was moved due to suspicious reasons. But if you're interested in traveling around a little bit, especially if you're a student, there's a chance that OWASP will pay your ticket and your flight. That might be interesting. In general, if you want to keep up to date what's happening at OWASP, we have the upcoming events. So either just search for OWASP upcoming events, or here's the website. The slides will be uploaded later. And yeah, that was already the quick part of today's evening. Okay.
Alright, looks good. Okay, then thanks for showing up. Thanks for listening to my talk. Today I'm going to talk about Kerberoasting. So Johannes already asked who's in the blue team, who's in the red team, who's in application development. I think Kerberoasting is not the typical topic that you would see at OWASP, because it has more or less nothing to do with application development, but goes rather into the infrastructure pen testing domain. So sorry for all of you who are here for application security. I tried to keep the talk both for the red team and the blue team. So I not only talk about the different attacks like Kerberoasting and golden tickets, but also how to mitigate and how to detect those attacks. The talk is only titled Kerberoasting, but I will.
Like last time,
huh? There's a bit missing. That looks better. All right, thanks. So I'm going to start off with Kerberoast 101. So what is Kerberoast? How does it work? This is the basis for the rest of the talk. I will then go over and talk about the main topic, Kerberoasting, as one of the one of my favorite attack vectors regarding Kerberos. And then in addition to this, because it fits into the topic, I will also talk about silver and golden tickets. And then I will wrap up with a summary and go over the points that I talked about. So jumping in, what is Kerberos? Kerberos is an authentication protocol that was explicitly designed for authentication over untrusted networks. And it was initially designed by the MIT and then adapted by Microsoft, some say bastardized, but Microsoft did its thing, and now it's their Kerberos implementation. It's still compatible with Linux, but it has some quirks that are specific to Microsoft. It's the default authentication protocol for any Microsoft Windows networks and Microsoft Windows domains, and that's since Windows 2000, so it's around for a while. And one thing is that it actually requires valid DNS names. So as soon as you use IP addresses to access a share, Windows automatically falls back to NTLM and no Kerberos authentication is actually used. Kerberos relies on tickets for authentication. So as soon as you have a ticket, the password is not transmitted over the network anymore. And that's why it's designed for untrusted networks. So basically the premise is that we don't trust the network, so we don't send the password over the network to authenticate against servers. And each ticket that you get is stored in the local credential cache on your machine. And I will get into what tickets are and what type of tickets exist later. So there are a few components that are important for Kerberos. And one of the most important things are service principal names. And service principal names, or SPN for short, are globally unique identifiers that describe or that identify a resource in the network. And for authentication, Kerberos relies on knowing these SPNs. And I've put the format here, so it's service class, host, port, or service name. Because it sounds a bit abstract, I put some examples here. So one of the most common that you will see in almost any corporate network is MS SQL servers. So you have the MS SQL service /sql.lab.local :1433 or SQL Express. And now you have the association between this SPN, which identifies the service, and, for example, the service account. I think in most corporate environments you're familiar with accounts that are somewhat like SVC SQL Server. And so you have the association between the SPN and the service account, so that Microsoft knows that the service account is able to run the MS SQL service. And that's what you need for Kerberos. Without any association between a service account and a service principal name, Kerberos authentication does not work. And there are a few possibilities, for example, to list the available service principal names in a corporate domain. The first is a Windows built-in binary that's set SPN -q *** will give you any service principal names for all service accounts and for all computer accounts in the domain. And this is one of the most important things. Every user that is part of the domain users group can by default see any SPN in the domain. And if you, for example, just want to know which SPNs are there for MS SQL servers, then you can, for example, define the service class, and then we'll list you, the set SPN will list every SPN for this specific service class. Apart from the service principal names, there are a few components involved in Kerberos authentication. First, the client principal, that's the user or computer that wants to access a specific resource in the network, and the server, which is responsible for serving this specific resource. And then, so for the untrusted part, Kerberos relies on a third party, which is the trusted third party, the Kerberos distribution center. And in a typical Windows domain, that's the domain controller. And on the Kerberos distribution center, there are two services running. The first is the authentication service, which is responsible for providing so-called ticket granting tickets that every user gets. And these ticket granting tickets are used to request so-called ticket granting service tickets, or service tickets for short. And so the ticket granting ticket is actually, you can, if you log into a Windows domain, you can issue the klist command, and you will see that you automatically get these ticket granting tickets. Then when you want to access, for example, an SQL server or an SMB file share, you will send the ticket granting ticket as well as the SPN of the service that you want to access to the domain controller, and the domain controller will issue a service request. And the domain controller first does not care if you have access to the service, but it will give you the ticket granting service, the service ticket. And in basically every talk you see about Kerberoasting or different attacks, there's one of these images. where they describe how the authentication workflow works. This is mine. So it starts with the authentication request, ASREC, which takes place when you log into the domain, and your hash as well as your username are sent to the domain controller. And if you have a valid combination, you will get the ticket granting ticket. If you have a valid ticket granting ticket, you can request a service ticket for any service in the domain, which is the third request. And the ticket granting ticket itself is encrypted with the hash of the KRBTGT account, which is the account that is on every domain controller. And that's what how Kerberos works in these untrusted networks, is that it relies on symmetric cryptography, because the tickets are encrypted with password hashes, and as the domain controller has all the password hashes, as well as the different clients have their own password hashes, they have keys that are only known to those two parties. But that becomes more relevant in the later phases. So you have a TGT on your own machine that you cannot read. Only the domain controller can read this TGT, because it's encrypted with an account hash that's only available to the domain controller. So then you request the TGS. You send the encrypted TGT as well as the service principal name that you want to access for the service that you want to access to the domain controller. And the domain controller issues a TGS service ticket that is encrypted with the password hash of the service that you want to access, meaning that the client cannot access the information in the service ticket, but the service that you want to access with the service account. This service can access the information in the ticket and can verify those information. And with the service ticket, you can then send the service ticket to the web server in this example. And as the service ticket is encrypted with the hash of the service account, the web server can decrypt the ticket, can look at the information, and can determine whether you're allowed to access these resources or not. If you're allowed to access the resources, you will get a success. If not, you will get a failure. And that's basically a really quick overview of how Kerberos works. Any questions so far? Okay. Because that's the basis for Kerberoasting. And what is Kerberoasting? Kerberoasting first was initially discovered and disclosed by Tim Meeting in 2015 for a Sans webcast, I think. I've put the link to the presentation slides in the references at the end of the presentation. So I think we will share the presentation, so you can also look at all the references that I used for creating this talk. And the main goal of Kerberoasting is to exploit weak passwords of service accounts. So without weak passwords, Kerberoasting is not possible. And as the goal is to crack these passwords, then you have the password of the service account, which you can obviously then use for lateral movement, privilege escalation, or persistence. For all the blue teamers here that rely on the mutual attack matrix for mapping attacks, I've included the reference to the mutual attack matrix in for every attack that I describe here. So, as I mentioned before, the issue in Windows networks is that any user can request a service ticket for any service in the domain. And as the service ticket is encrypted with the hash of this service account, we can extract the encrypted material and can basically do a no plaintext attack. So we will try hashes, and it's basically a password guessing attack, because we know that it's encrypted with the hash. So we just try to guess the hashes, decrypt the ticket, and if we get a valid ticket, we know that this is the password of the service account. And the problem is that you don't need any privileges. You don't need administrative privileges to get the ticket for any service, and the service does not even have to be active. So, I mean, if you clean up your Active Directory environment and don't have any old service accounts with weak passwords, then you shouldn't be worried about Kerberoasting, but I would guess that in most corporate environments that's not the case. So that's why Kerberoasting is still an issue and works very often, yes?
But if service is not active, what do you gain with having its password?
Mostly these service accounts. Oh, well, what I mean is, for example, you have an SQL server. You set up the account for the SQL server. You decommission the SQL server, but the service account for the SQL server is still in Active Directory.
Yes, but what can you do with the password when the service is not active?
The service doesn't have to be. One of the biggest issues with Kerberoasting is that many service accounts are over-provisioned. So if you have, for example, a service account that was responsible for running your SQL server, it has most definitely local administrative privileges. And if you really use that account for different SQL servers that are, for example, still active, you can then access the SQL service with local administrative privileges and could, for example, dump the credentials on these servers. Okay. SPN scanning is one of the measures to find these service accounts and exploit them. So again, set SPN is one of the manual measures. You can just list every SPN and every service account in the domain and look for targets that are that look interesting. For example, SQL servers, SharePoint, and so on. Or you could use find PS service accounts from Sean Metcalf, which does it automatically and looks for Kerberoastable accounts that are service accounts that have at least one service principal name associated with them and have the property password never expires. Then you can use that target SPN that you determined and request a ticket for exactly this SPN. The ticket is then cached into your local credential cache, and Mimikatz has a function to dump the ticket from the local credential cache. And this gives you a Kirby file, which you cannot directly use with John or Hashcat, but there is a Python script that's called Kirby to John, and you can use it to extract the relevant material to feed the ticket directly into John and crack the password of the service account. If you want to use Hashcat, there's an SED command to switch out some parameters so that Hashcat actually also understands the format. So this is one of the more manual ways to do it, which I personally find a bit too complicated. And the good thing is that because of the time that has passed since the attack was published, most of these things have been automated completely. And there are two tools that I generally use. The first is a PowerShell script that's in work Kerberoast, which is also part of the Empire framework for those for the red teamers here, and Rubeus. Rubeus is a relatively new tool developed by Harmjoy from SpectreOps. It's written completely in C#, but you can also compile it to a DLL, and you can just put it into a PowerShell script if you like PowerShell more. And it's a toolkit that was just completely developed under the premise to attack the different, or to conduct the different Kerberoast attacks. And that's actually all you gotta do. So all the steps that I previously mentioned are automated by Rubeus with the Kerberoast command, and it directly gives you a file that you can feed into Hashcat and crack the passwords for the service account. And I've also put the Hashcat command, and let's see if that works, and I can give you a quick demo. So in the test lab, I have one SQL server that has SQL Server Express on it. I have configured the service account, and if you do set, oh yeah. No. So if you do set SPN, it's cute.
Jetzt ist noch nicht größer geworden.
Yeah. So if you do set SBN, you can see all the different, and there are not many service accounts in my test lab, so these are all the default SBNs that you can see. So just for example, you have the SQL server, and then you have the standard MS SQL servers. WSMan is for Windows remoting, TermServe is for remote desktop, and host is the access to, for example, stuff like direct access to the schedule, the task scheduler, and so on. And you also have the SQL admin service account that also has the MS SQL SPN associated with it. So if you then go into okay. Sometimes you win, sometimes you lose.
The demo gods are not happy.
No. Normally, it should give you the ticket information in the format so that Hashcat can understand this ticket information, and then you can just feed it into Hashcat. It will just do its magic, and if you're lucky, you get a service account password. And in the past, I've used it to access servers just because it was, as I mentioned, over provisioned. So the service accounts actually had local administrative access to a variety of servers. So by doing the Kerberoasting, cracking the service account, I got local administrative access to many servers and could use that to pivot further into the network. And let's go back into the slides. And what can you do to mitigate Kerberoasting? For one, service accounts should have complex and long passwords, because, to be honest, service accounts, you mostly set them up once, give them a password, and then you don't touch them anymore. And that's why we recommend for customers where we can do successful Kerberoasting passwords of a length with greater than 28 characters. 28 characters because Hashcat is actually not able to crack passwords that are longer than 28 characters because of how it's implemented. Another possibility to mitigate Kerberoasting is using group managed or managed service accounts. Those are service accounts that are actually managed by Active Directory, and Active Directory rotates the passwords and also sets passwords that are, I think, 40 or 50 characters long. So you don't have to care about passwords. In addition, you should always limit the privileges of service accounts. I've seen service accounts that were Kerberoastable and in the domain admin group. That's basically the worst thing you could do. So try to limit the actual privileges of these service accounts to that what these service accounts actually need. And also, the Kerberos protocol supports AES encryption, and you can fall back to RC4, but you can also configure your host to only allow AES encryption. And the Kerberoasting attack that's currently in use relies on the fact that RC4 encryption is not really slow and doesn't have any protections against brute force. So if you still have RC4 in use, Hashcat can go through the passwords pretty quick. So instead of RC4, just use AES. Now for the blue tuners, how do you detect Kerberoasting? There's no default way. So there's no magic switch that you can turn on in your Zeem to detect Kerberoasting. First, you would have to enable audit Kerberos service ticket operations, so that on your domain controller, so that every time a ticket is requested from a user, that it's logged. And then you have to check these logs for anomalies, because if someone is Kerberoasting with these standard tools, you have one user account that requests service tickets for a wide range of services within a short period of time. And if you see that, that's mostly something that should be suspicious. So if you monitor for a high frequency of these Kerberos ticket requests in a short period of time. You don't have a sure way of telling that Kerberoasting is in use, but you have indicators that you can further investigate too. And because Kerberos is Kerberos and the ticketing process is a thing that occurs frequently in large domains, you have obviously a very high rate of false positives because you have user accounts or scripts that do request a lot of service tickets in a short period of time. So again, there's no simple way of detecting it. There's always work involved, and you need to create rules to monitor exactly for these events. Okay, any questions regarding Kerberoasting? Yes.
You said that Hashcat can only support to 20 characters.
Yes.
It would be easier to use a John the Ripper and migrate the function to it.
Not sure if I understood the question.
Because
Jonas.
Hashcat supports 28 characters,
Mhm.
and John the Ripper can support basically up to 32.
Okay.
And you can import the option for it to generate the password.
Even if John supports 28 characters, cracking a completely random and complex password with 28 or 30 characters is, in my opinion, nearly impossible. So if you go above 25 characters for a service account, it doesn't matter which tool you use to crack it, you won't crack it anytime soon.
Yeah, but if you have extensional amount of resources, then you can basically get it very fast.
I haven't tested it because I don't have access to those resources, but might be possible. I can't say anything definite. I don't know, to be honest.
I mean, we can lend you some servers if you want to test it.
I'm not sure. No, but yeah, if you go above 25 characters, then you need a lot of money and a lot of resources to crack this. So going above 25 should be plenty, especially in combination with AES encryption.
Or would it be easier to implement a two-factor authentication on this system?
Those are service accounts. Those are machine-to-machine accounts. You can't really have two-factor authentication for machine accounts.
Okay.
I mean, if there's a solution for that, I'm always I'd like to hear it, but I don't know of any way to implement two-factor authentication for machine accounts and service accounts. Yes?
Is it also expect to require information for the attacks from network traffic, or is it required at your own machine device?
So the basis for this attack is that you have compromised one machine within the Active Directory, or have at least one pair of valid credentials for the domain that you want to attack. So you need the read-only access to the domain.
Okay.
So either credentials or direct access on a workstation within the domain that has at least one domain joint account logged onto it.
So it's not enough to see that external.
I think, but I'm not sure of this, that it's possible to extract the key material from network traffic, but I haven't tried it because this is way easier than trying to extract it from network traffic.
And it's in network traffic, it's unlikely to be RC4.
It's the same protocol. So
It's a default, or
the tickets are encrypted, but the network traffic between hosts is not encrypted. So you can extract the encrypted material from network traffic. There's no additional encryption on the network.
Do you know which applications still require RC4? Or
I'm not sure, but if you don't configure it, you can force the Windows client to fall back to RC4. And you need to explicitly deactivate it for the service accounts to not support RC4 anymore.
But you have no idea what to do if the applications are, for example?
I mean, there might be some legacy applications that still require RC4, but I'm not aware of any.
No.
I
think it's mostly a problem if you have old Windows domain controllers and stuff like this in your domain because of supporting legacy applications.
Yes.
And if you, for example, maybe have some Windows 2003 domain controllers still there, then you can't disable it because they won't work anymore.
True. I'm not exactly sure when AES was introduced into Kerberoast, but I think it was somewhere around Windows Vista, Windows Server 2008. So yeah, if you still have Windows XP or Windows Server 2003, it might not be possible to completely deactivate RC4. But you shouldn't have those in your domain anyway. So, okay, one more question.
Yeah, and how do you deactivate RC4? Is there a registry key or?
You have to disable it in the settings of the service accounts. So if you go into your user and account management and go to the service accounts, in the properties you have, I think it's in the general field, you have the options to only support AES encryption and disable RC4. Okay. Then onto silver tickets. Silver tickets are not a technique to gain access or to escalate your privileges, but those are purely for persistence. So you have compromised the domain, you have compromised the service account, and you want to persist, but you don't want the blue team to notice you. Then you have silver tickets as a stealthy way of persistence in the Windows domain. And the goal of silver ticket attack is to forge valid service tickets without contacting the domain controller. And for this, you require either the password hash of the user or the computer account that the service is running on. And the problem is that the server, when you send it the TGS, the service ticket, it does not verify it with the domain controller. So you can basically authenticate against the server without talking to the domain controller at all, as long as you know the password hash of the service account that you of the service that you want to access. And again, there's no attack directly related to silver tickets. Silver and golden tickets both fall under the pass the ticket attack. Pass the ticket is basically exactly like pass the hash. You request a ticket and then write it into memory or into the credential cache for further use in your Windows session. As I mentioned, you need the password or NTLM hash of a service account to forge valid service tickets, silver tickets, and you can get those either through Kerberoasting or through local administrative access on a server and dumping the credentials on the server. When you create a silver ticket on a compromised host, you don't need a TGT for that because you already have the information that the domain controller normally uses to encrypt the service ticket, and you do not need to request the service ticket from the domain controller, but you can create a service ticket to access the service directly on your compromised host. So the domain controller is never contacted and you cannot monitor for any events on the domain controller. And again, the target server itself does not verify the information in the ticket with the domain controller because it trusts that the ticket information is valid because it's encrypted with its own hash. And normally only the domain controller and the machine itself should have this hash. So that's why the trust is here the biggest problem. And you can recreate the silver tickets anywhere and use it from anywhere within the Windows domain. And Mimikatz actually can do it. Mimikatz has a ready command to create silver ticket. You basically just have to give it one account that you want to use, and the account ID. You need to specify the domain. That was previously one way to detect forged tickets because it didn't include the domain name in the actual ticket because it's not needed. So you could just monitor for tickets that have an empty field in the domain name. So that's why Mimikatz now asks you for the domain name to be more stealthy. The SID is the SID of the domain that you're in that you can get with either PowerView or the Active Directory PowerShell module. The target is the server that you want to access. In this case, it's the domain controller. The RC4 is the hash of the computer account from the domain controller. And the service is sys, so you can access the file system of the domain controller. And with the PTT switch, you can directly pass the ticket into memory. So if you issue this command within a command line in Windows, you can directly access, for example, with the dir command, the domain controller C-share from the command line. The problem with server tickets is that it's behavior that is working as intended. So there's no patch, there's no fix for it. The only thing you can do against server tickets is protect your assets and protect your hashes. It's the same mitigations as Kerberoasting, obviously, because with Kerberoasting you can get the password that you need to create server tickets, but there's no way that you can just patch anything so that server tickets work anymore, because you just abuse configurations and behavior that is planned by Windows. There are ways to detect server tickets, but again, it requires a bit of work, because you can, and this is a bit of old information, and it depends on which version of Mimikatz is used to create the server tickets. But previously, you could identify server tickets with blank or with empty domain names, and yeah, you can actually see for the you can actually watch for the FQDN in the domain field, where it should just be the domain name. Again, most importantly, when it comes to detection, I'm not a blue teamer. I've worked a bit with proof of concept, but I've never done it on a large scale. So if I missed anything, or if you're aware of any means to detect server tickets, I'd love to learn.
How long does a ticket usually last when you get it the regular way? They don't last forever, right?
They don't last forever, and it was there was a way to detect golden tickets, because when Mimikatz created the golden tickets, they explain on the next slides. It created the golden tickets with a expiration time of 10 years, and that was not normal. So, but the problem is the default Windows event for account log on with a Kerberos ticket did not log the expiration time of the ticket. So even if you had a SIEM, you could not watch for golden tickets because the expiration time was not logged by the Windows event logger.
Could you turn it around for silver tickets and say you want to alert if a machine is talking to a service without talking to a domain controller first?
That might be possible, but I'm not sure. That's something that
complex.
could be.
You will have a lot of false positives.
Yeah.
Because you need an IDS, an intrusion detection system,
Yeah.
which does pattern matching on the traffic that goes over the network, and
Yeah.
that will not work.
So not paid by Microsoft, but one product that's actually able to detect those kind of attacks is the Advanced Threat Analytics solution from Microsoft, because they integrate so deeply into their own environment that they are able to correlate events and detect if there is a silver or golden ticket in use. But that's the only solution that I'm personally aware of that's able to detect it reliably.
I think they look at network traffic
Yeah.
as
Yeah.
well, doing that.
Yeah, ATA is for network traffic, ATP is for host-based security, and so they correlate network events to look for silver tickets and so on.
Also heavily based on Windows events.
Yeah, I think they do both.
Yeah.
Okay, so that's silver tickets. Golden tickets are similar to silver tickets. One of the biggest differences is that you do not forge the service ticket, but you forge the ticket granting ticket. And for that you need the password account of the KRB TGT account. So in order to create a golden ticket, you need administrative access to the domain controller. So this again is a pure persistence technique to do stealthy persistence. If you, for example, compromise the domain admin and do not want to add your own account to the domain admin accounts, because that group is mostly heavy monitor, you can issue golden tickets to get around the monitoring. and use golden tickets to access the services in the network without the blue team noticing if they do not have explicit measures in place to watch for golden tickets. It's the same meter tag reference as the silver ticket. So as I said, you need the KRB TGT password hash because the TGTs are encrypted with this hash. So if you have access to the domain controller and can dump the hashes of the domain controller, you can use the hash to create your own KRB TGT ticket. And again, like the silver tickets, you can create it on any host in the network and you can use it with any service in the network. There is still communication with the domain controller because you do not have the authentication request because you forged it on your own system, but you can use that forged TGT to request a service ticket for any service in the domain. For example, the SMB share service on the domain controller or the host service on the domain controller. And the problem is that the golden ticket is a valid TGT Kerberoast ticket, so it does not differ from the tickets that you normally get with when you request a TGT from the domain controller. Again, in the past it was easy to detect because the developer of Mimikatz put some strings into the tickets that would uniquely identify it as a Mimikatz ticket. But since I think 2 years, those strings are gone, so it looks like a valid Kerberoast ticket, and you cannot differentiate it from normal TGT that you would get from a domain controller. To create the golden ticket, you need the domain name, again the domain SID, the KRB TGT account password, and the user ID for impersonation, but you can use any arbitrary user ID to create it. Again, Mimikatz does it. You need even less parameters than the server ticket. You don't need the target. You don't need any target system or target SPN, but you just need the hash, the domain, and the user for impersonation. Again, with the pass the ticket switch, it will directly go into your memory, and you can use it from there as if you requested it from the domain controller. When you issue the golden ticket with Mimikatz, you can also tell Mimikatz in which groups you want to be with the golden ticket, but by default it will add you to the domain admin group in the ticket, so you have full compromise of the domain and have a full persistence mechanism without any new user that you need to add to the domain admin group.
Just a question before, on the server ticket you got in Mimikatz Kerberoast golden, it's right?
Yeah, it's one command.
Oh, okay.
And the only difference is that this is the RC is the hash that it's used for encryption, because with the silver ticket it was the hash of the service account. With the golden ticket it's the hash of the KRB TGT account. And we don't usually do golden tickets during penetration tests without an explicit okay from the client, because to get rid of a golden ticket so that it doesn't work anymore, you actually need to change the password of the KRB TGT account twice, because Windows caches the last two versions of the password, and it can have unintended behavior within the domain and a high load on the domain controller, because every user has to have request a new TGT for himself. Normally they have a valid, normally they have an expiration time of a few hours, I think, or at least up to an hour. So you would have a high load if you change the KRB TGT account. So most of the time our customers say, no, please don't do it. Okay, for mitigation, as with the silver tickets, it's intended behavior. There's no fix, there's no patch that you can apply to your domain to get rid of golden tickets, and the only way to mitigate golden tickets is to protect your domain admin accounts and your domain controller. So the usual measures, privilege access workstations, don't give normal users domain admin rights, and etc. I still have to say it, but I still see it. And apart from that, you can actually regularly rotate the KRB TGT account, just to be sure. If you have someone in the network that has issued a golden ticket, if you rotate it regularly, they are only in the network for like maybe a few months, but not indefinitely. And yeah, detection, same thing. It's hard to detect because the expiration of golden ticket or Kerberos tickets is not locked. NSATA is again able to detect golden tickets, but only when they are actively used. And indicators are again a blank field or domain of pen in the domain field of the tickets. And the two events that you have to look for are account logon and admin logon. Same disclaimer applies. I'm not a blue teamer. If you know any way to detect silver and gold tickets, I would like to hear about it. Okay, so wrapping up. Kerberoasting is an attack that exploits weak passwords and over-provisioned service accounts. Golden and silver tickets are measures for stealthy persistence in a network that you have already compromised. And to mitigate those attacks, you need service account passwords that are greater 25, 28 characters. You should look for minimal privileges on service accounts, that they only have those privileges that they absolutely require to work. And you should protect your, obviously, domain controllers and domain admin accounts. Any questions? Yes.
So I had a quick Google.
Mhm.
I know nothing, right? So I had a quick Google because of the question in the back, and your comments are around don't use RC4. And there was an RFC 8429, so the internet standard, and the deprecation of triple DES and RC4 and Kerberos, and that was released officially in October 2018, and the draft was 2017.
Okay.
So it's just things take a while for the internet standards to catch up with the red teams.
Yeah.
And then the organization takes obviously
20 years more.
There are ways to mitigate Kerberoasting by disabling RC4, but it's not trivial. It's hard to automate for all service accounts across the domain. And I think Spectros recently put out a new blog post that even if it's explicitly disabled in Active Directory, you can still force Windows somehow to fall back to RC4 and still have the possibility to do Kerberoasting in networks where RC4 should be disabled. So legacy is still a problem for Windows. Any further questions?
Practical question. The password links, can this be detected by the Tenable network scans?
I don't think that Tenable network scans does.
No idea how it works actually.
So if you do a network scan in the network, Tenable won't detect Kerberoasable accounts.
Okay, so they can either detect RC4 for instance.
I don't think even that, because you scan hosts, and those are not host-based configurations, but Active Directory-based configurations. So there is a tool that's called Pingcastle. It's an open source tool, and it does Active Directory auditing. And with that, you can find accounts that have, for example, password never expired set and password last change, for example, in 2013. And those are pretty good indicators for Kerberoasable accounts. Because if the password hasn't been changed in like 5 or 6 years, you can hope that it's a weak password when it was first set, because back then this attack was not known.
But you would never be able to audit AD to see if there's a short password.
No.
Because if I set a short password on an account and then I change the account to have a complex password and a password length,
no,
but potentially no expiration or no change, it could still be a short one-character password.
Exactly. So the only way to audit passwords in Active Directory is to dump the Active Directory database and run it through Hashcat. Yes?
Isn't it a strange idea to use passwords for service accounts anyway, and why not using just some randomly generated key or a password based on a randomly generated key?
It's a good question. I mean, it's how Windows works. Service accounts are normal user accounts that just have a service principal associated with them. So just from an Active Directory standpoint, you cannot distinguish a normal user account and a service account, because it's both the same. There's no, apart from the group managed service account, it's not a dedicated service account class in Active Directory. It's just a normal user account that you give the rights to run a service.
So I could generate a key and then make an hex dump of it and use it as password.
For example, that's, I mean, randomly generated passwords for the service accounts are exactly what what I was talking about. If you have a 40-character password, there's, in my opinion, no way in hell someone would crack it within a reasonable time. Yes?
Is there anything to consider when changing the KRB TGT account's password, except of the load you mentioned?
To be honest, I've never heard a customer who changed it. So it's only theoretical. I've never seen anyone do it, especially not in a large-scale enterprise.
Microsoft has an article on it. I
Okay.
read it once, but it's very long and it will never happen in a large environment.
Exactly. So yeah, as I mentioned, we always ask our customers if we should do it for demonstration purposes, and I've not yet once had a customer say yes, please do it, because they don't want the effort to actually change it twice. Yes.
Does using the current Microsoft security policy mitigates Kerberoasting?
I'm not sure what you're referring to. Security.
There are some. There's a set of group policies,
Mhm.
very long group policies, which alter a huge lot of security settings in Active Directory.
Mhm.
And I'm just curious to know if using these would mitigate the effect.
Good question, but I cannot answer.
It's working as an aid from Microsoft side. So there's no policy in Microsoft's Active Directory that could disable Kerberoasting.
No, maybe there's something to enforce AES, for example, or something like this.
I would have to check the rules.
Something that you set on the account level. So for each service account, you have to set this. If you want to have it on all, then you just write a PowerShell script that will look for service accounts and set it on everything.
But using a PowerShell script wouldn't enforce it right at the beginning. So you are dependent on something like a batch job that runs maybe once a month, once a day, or something like this to detect these accounts. It's very hard for a large environment to enforce it with by using a PowerShell script.
So you're looking for a GPO that does not allow you to use RC4 for the account setting.
Exactly.
But I think aren't GPOs just applied locally to the computers?
There are GPOs that are applied to domain controllers, of course.
Okay, and to be honest, I'm not really sure if there are GPOs that actively change settings in the Active Directory itself. So if there are GPOs to change configurations of user accounts, I can't answer that. So I would have to look into the security policy if it actually mitigates or tries to mitigate Kerberoasting. But as of now, I cannot say anything about it because I actually haven't heard about it.
Okay, thanks.
Okay. Any further questions? No, then thanks. These are the references and these are the 4 tools. But as I said, the slides will be uploaded to the OWASP page sometime soon.
Very soon. In the future.
And there are also the references and the tools that I used, or that I regularly use during pen tests.
So I just have a few more infos and questions, and then we can go to the bar. So, who would be interested in doing something like that and some kind of workshop? So let's say if on one of the next meetups, we would say, for example, we have this area where we have a talk. We will also have a separate area for smaller groups that can sit together and do these things like hands-on, like you bring your laptop, you get a virtual machine, for example, and then for 2 hours or so, we would work on exactly something like that. For whom would that be interesting? Okay, that's more than one. Okay, so that's one of the ideas maybe. For the next OWASP meetup, we don't yet have a talk. So unless someone comes up with something better, one of the ideas is that Jan and me will talk about how to use Terraform to create your own enterprise environment for pen testing, where you can test these kind of things and others, like especially Active Directory stuff. So if you have any ideas for a talk, or you would like to present something, then just hit me up via Meetup or here later, or via whatever means. From the people who are here the first time today, who found us via Meetup? Okay, who found us via different means, like dragged by a friend or something? Okay, so that's this time like 50-50. Usually we see that Meetup has a very strong force. Besides Meetup, where we will also put, like today or tomorrow or the day after tomorrow, the save the date for the next appointment. We also have mailing lists, which I think no one is using besides me, to write about the next meetings. And also on the OWASP pages you can find the German Stammtisch Initiative. So there are different meetups like this in different kinds of formats all across Germany. And we also had a interesting talk during the last few weeks, because we oftentimes people call us a chapter, like OWASP chapter Frankfurt, and if you look at the States, then you have a lot of cities who are chapters, and somehow that made it into our description page, and then there was a big outcry because chapters like one of the motor clubs with your own agenda and everything. So do me a favor, don't call us a chapter, or the Americans will rip my ass off. And, huh?
You can also say charter.
Yeah, no, we would just stick with Meetup or Stammtisch as a joke. Because I don't need that overhead. And so then, thanks for coming. I hope everyone learned something. I certainly learned a lot again. And yeah, so I hope I see a few of you at the bar. If you have any questions about the meetup, ideas, suggestions, hit me up via Meetup or later at the bar. And thanks for coming.